So for the mean and the standard deviation of a binomial distribution, we're going to do another practice example. I'm giving you the chart already, and X is representing the number of doubles in 4 attempts when rolling a fair die. N is 4, and the probability is 1/6. Because you could get rolling snake eyes, which is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 out of 36 reduces to 1/6. And if you were to calculate the mean, you would do the value times its probability. Value times its probability. Value times its probability. And if you were to actually calculate it, it works out to, make sure you calculate it to 0.667, around there. There is an easier way. The probability to get 0.667, there's a formula, and it's simple. N times P. If we would have just done 4 times the 6th, it gives us 4/6, which is 0.6666 repeating, or about 0.667. I believe this formula is also found in your formula sheet, so you do not have to memorize it. It will have m of x, or mu of x, equals np, n times p. And again, there's a shortcut for standard deviation as well. Now remember, for this one, it's a nice long formula where you take the mean and you take away the value, square it, and times it by its probability. You add it to the mean, take away the value, square it, times it by its probability. Oops, getting ahead of myself. Take the mean, take away the value, square it, times it by the probability. The mean, take away the 3 this time, square it, and times it by its probability. The mean, take away the value, square it. Take a minute and do those calculations. If you do these calculations correctly, I think you end up with about 0.556. And remember, standard deviation is you square root this number. So if we square root 0.556, we get an answer around 0.746. And of course, there's another formula, another shortcut that we could do in lieu of this. And it is a given to you formula as well, so I'm going to box it in. It's a little longer, but again, you don't have to memorize this. I think even on the formula sheet, it talks about this being for binomial distributions only. The standard deviation is the square root of NP times 1 minus P. So if we were to do that instead, N is 4, P is 1/6, 1 minus P is 1 minus 1/6, which is 5/6. And if we were to multiply these, we get 20 over 36, 0.555555555. That's why I kind of rounded it to 6. And the square root of that 0.745356, something like that. Which rounds up to 0.746. So there are quicker ways to get the mean and the standard deviation, but you can always do them by hand.